February 23, 1943, the Kummersdorf Proving Ground, 50 kilometers south of Berlin. Hauptmann Klaus Dietrich stands before a weapon that should not exist. Not in this form, not with these specifications. Not from a nation that his technical education taught him understood nothing about precision engineering. The Browning machine gun, caliber .50, M2, heavy barrel. Serial number stamped into the receiver reads 34721. Captured 3 days earlier from a disabled M4A1 Sherman near Sbeitla, Tunisia. Shipped north through enemy air superiority at extraordinary cost, because the Heereswaffenamt Technical Intelligence Section demanded immediate analysis. Dietrich commanded the machine gun testing section at Kummersdorf since 1941. His previous 20 months evaluated 47 different automatic weapons from 18 nations, Soviet DP 28 seconds, British Bren guns, French Hotchkiss designs, American M1919S in 30 caliber. Each weapon told a story about the nation that built it. Engineering priorities made visible in steel and mechanical tolerances. The M2 tells a story that contradicts everything Dietrich learned in 7 years of weapons engineering. At 84 pounds without tripod mount, the weapon masses nearly 8 times the weight of the ammunition belt it fires. The barrel alone weighs 24 pounds. German doctrine emphasized weight reduction, portability. The MG-34 achieved 900 rounds per minute at 26 pounds total weight. The newer MG-42 delivered 1,200 rounds per minute at 25 pounds. American designers built a machine gun that weighs more than 3 MG-34s combined and fires half as fast. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. Dietrich's testing protocol begins with disassembly, understanding mechanism, and before evaluating performance. The M2's receiver splits open to reveal 44 major components, not the 150 parts required for the MG-34, not the 87 pieces needed for the Browning automatic rifle his section tested in 1942. 44 parts performing functions that German engineers required twice that number to accomplish. The operating system defies accepted engineering wisdom. No gas tube extracting propellant pressure to cycle the action. No piston converting that pressure to mechanical motion. No adjustment screws compensating for different ammunition types or environmental conditions. The M2 operates on short recoil. The barrel itself moves backward with each shot. Uses that rearward motion to unlock the bolt, extract the spent cartridge, cycle the firing mechanism. Lieutenant Friedrich Weber, Dietrich's assistant for 5 years, removes the bolt assembly from the receiver, studies the locking mechanism in morning light filtering through the Proving Ground's observation windows. The design is wrong. He learned at the Technische Hochschule Berlin that moving barrels introduce alignment problems, accelerate wear on locking surfaces, reduce accuracy potential. Every modern machine gun since Hiram Maxim's 1884 design utilized gas operation specifically to avoid these problems. American engineers built their heavy machine gun using the mechanism their own textbooks condemned as obsolete. The testing begins with standard evaluation procedures, accuracy assessment at 100, 300, and 600 meters, 5-shot groups from bench rest mount, measure dispersion, document consistency. The M2 fires the .50 Browning machine gun cartridge, 12.7 mm by 99 mm. Muzzle velocity approaches 850 meters per second. Kinetic energy approximately 3 times the German 7.92 by 57 Mauser cartridge. At 100 meters, the 5-shot group measures 87 mm center to center. At 300 meters, dispersion increases to 243 mm. At 600 meters, the group opens to 419 mm. Weber records each measurement in the evaluation log with Prussian precision. The numbers reveal acceptable but unremarkable accuracy, sufficient for anti-personnel and anti-material roles at combat ranges. Nothing exceptional, nothing justifying the weapon's excessive mass or the Americans' obvious pride in the design. The sustained fire evaluation begins at 0900 hours. This test reveals whether theoretical performance translates to battlefield reliability. German doctrine established specific protocols. The MG-34 required barrel changes every 250 rounds during sustained fire to prevent overheating. The MG-42's higher cyclic rate mandated changes every 200 rounds. Both weapons demanded careful thermal management. Precision-machined parts suffered warping and dimensional changes under extreme heat. The test protocol calls for firing 100 rounds. Pause 30 seconds for observation. Fire another 100 rounds. Continue until thermal failure or ammunition exhaustion at 2,000 rounds total. Weber loads the first cloth belt. 250 rounds of captured American .50 caliber ammunition. Ball cartridges mixed with tracer rounds for visual observation. Dietrich depresses the trigger. The M2's distinctive report echoes across the Kummersdorf firing range. Deeper and heavier than the MG-34's sharp crack, more authoritative than the MG-42's buzzsaw snarl. The weapon fires at approximately 525 rounds per minute. Slower than both German general-purpose machine guns. Each round sends the massive barrel assembly backward through its recoil stroke before the heavy spring drives it forward again to chamber the next cartridge. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. The first 100 rounds fire without malfunction. Weber waits 30 seconds. Times the pause with his mechanical stopwatch. Dietrich resumes firing. The second 100 rounds complete. The barrel radiates heat visible as shimmer in the cold February air, but the weapon continues functioning. Third, 100 rounds. Fourth, fifth. At 500 rounds, the barrel temperature exceeds any safe operating parameter for German machine guns. Dietrich expects catastrophic failure. Dimensional changes in the barrel causing misfeeds. Warped receiver rails preventing bolt travel. At minimum, the accuracy degradation that renders the weapon tactically useless until cooling and maintenance. The M2 continues firing. 600 rounds. 700. The cloth ammunition belt feeds smoothly despite barrel heat that would ignite most fabric materials. 800 rounds. Weber interrupts at 900 rounds, removes his leather glove, extends his bare hand toward the barrel from 20 centimeters distance, pulls back immediately from radiant heat, estimates barrel temperature at 400 degrees Celsius, hot enough to ignite gasoline. The weapon last fired 11 seconds ago and shows no sign of catastrophic failure. They resume firing after the mandatory 30-second pause. 1,000 rounds total, 1,100, 1,200. The barrel now glows dull red in the shadows beneath the receiver. Still the weapon cycles, still the mechanism functions. At 1,500 rounds, Dietrich ceases fire not because of weapon failure, but because the captured ammunition supply approaches exhaustion. The M2 fired 1,500 rounds in sustained bursts over 18 minutes without any malfunction. No misfeeds, no extraction failures, no thermal damage requiring barrel replacement. Weber's testing log records. 0 stoppages per 1,500 rounds fired. The number contradicts 2 decades of German machine gun development philosophy. The MG-34, celebrated as the world's first true general-purpose machine gun when introduced in 1935, recorded stoppage rates between 30 and 45 per 1,000 rounds under field conditions. The improved MG-42, rushed into production in 1942 specifically to address MG-34 reliability problems, achieved 18 to 24 stoppages per 1,000 rounds. The American weapon, built using obsolete design principles and weighing 3 times what German doctrine considered acceptable, demonstrated reliability exceeding the best German engineering by an order of magnitude. Dietrich requests the detailed technical assessment. Weber disassembles the M2 after firing, examines each component for wear, fouling, or thermal damage. The bolt face shows powder residue but no dimensional changes. The barrel, despite firing 1,500 rounds in 18 minutes, displays no warping, no erosion beyond normal use patterns. The extractor maintains proper tension. The ejector spring retains its original specification. Most significantly, The locking mechanism shows minimal wear. The rotating bolt head that German engineering predicted would fail first under the stress of a moving barrel system functions as smoothly after 1,500 rounds as before testing began. The mechanism's simplicity explains its reliability. Gas-operated weapons accumulate carbon fouling in narrow gas tubes at rates that eventually obstruct pressure flow and cause stoppages. Pistons require lubrication that burns off under sustained fire. Adjustment screws allow tolerances to shift under extreme temperatures. The M2 eliminates these failure points entirely. The weapon's own recoil provides operating power. The violent rearward motion of barrel and bolt shakes loose carbon deposits before they accumulate to critical levels. The heavy mass absorbs thermal stress that would damage lighter components. American engineers achieved superior reliability not through precision manufacturing tolerances, but through mechanical brutality. The weapon weighs enough to survive operating stresses that would destroy more sophisticated designs. The ammunition capacity evaluation reveals the second fundamental difference between American and German machine gun doctrine. The M2 feeds from metallic link belts. Each link weighs approximately 7 grams, holds 1.50 caliber cartridge. Links separate as each round feeds into the chamber, fall away to either side of the weapon. A crew can link individual belts together indefinitely. Create ammunition supplies limited only by available transportation capacity. German MG-34 and MG-42 crews operate with 50-round belts or 75-round drum magazines. Reloading creates pauses in fire, vulnerabilities that enemy forces exploit during assaults. American M2 crews can maintain continuous fire for hundreds of rounds without reloading. The tactical implications transform machine gun employment from a defensive weapon, requiring careful ammunition management, to an offensive tool supported by unlimited supply. Dietrich's report to the Heereswaffenamt documents these findings with characteristic German thoroughness. He notes the M2's excessive weight, its slower cyclic rate compared to German weapons, its obsolete recoil-operated design. Then he adds the evaluation that condemns 3 decades of German machine gun development philosophy. The American weapon demonstrates reliability unprecedented in automatic weapons development. Stoppage rate during sustained fire testing measured 0 per 1,500 rounds. Comparable German weapons demonstrate stoppage rates 15 to 45 times higher. The M2's mechanical simplicity and excessive mass provide operating margins that absorb environmental stress and fouling effects that disable more sophisticated designs. American doctrine apparently prioritizes sustained fire capability and supply abundance over weapon weight and individual weapon sophistication. The report reaches Berlin on February 27, 1943. Generates immediate discussion at the highest levels of Wehrmacht technical command. The implications extend beyond simple weapon comparison. They reveal fundamental differences in how Germany and America approach the industrial dimensions of modern warfare. German machine gun doctrine since 1918 emphasized the general-purpose concept, one weapon adaptable to multiple roles through mounting changes and accessory swaps. Light machine gun with bipod for squad automatic weapon role, medium machine gun with tripod for sustained fire support, anti-aircraft machine gun with specialized sights and mounts. This versatility required complex mechanisms, precision manufacturing, extensive training for crews to exploit each configuration. American doctrine emphasized specialization. The M2 heavy barrel serves in ground roles. The AN/M2 aircraft version uses lighter components and higher cyclic rate for airborne applications. The M1000 919 in 30 caliber provides infantry squad automatic fire, each weapon optimized for specific purpose rather than attempting universal adaptability. German weapons represent engineering sophistication. American weapons represent industrial capacity. The philosophical difference manifests in production statistics that Dietrich's report cannot ignore. German factories manufactured approximately 354,000 MG-34 machine guns between 1935 and 1945. Sophisticated weapons built by skilled workers using precision machining processes. In early 1943, German planners project MG-42 production, reaching 421,000 guns by war's end. 775,000 German machine guns total across a decade of production. American factories manufactured 393,000 M1919 Browning machine guns at a single converted automobile factory, the Saginaw Steering Gear Division of General Motors. One facility converted from peacetime production accomplished more automatic weapons output than Germany's entire pre-war and wartime machine gun industry combined. M2 Browning production across multiple American factories exceeded 400,000 units by late 1942, before most German planners acknowledged that America's industrial mobilization posed an existential threat to German victory. The numbers reveal a nation that treats machine guns as disposable commodities rather than precision instruments requiring careful maintenance and resource management. The cyclic rate discovery occurs during the third day of testing. Oberst Heinrich Schreiber arrives from the Waffenprüfwesen Technical Evaluation Office in Berlin. His assignment: verify Dietrich's findings and assess whether German industry can replicate the M2's reliability advantages. Schreiber spent 19 years in weapons development, participated in the MG-34's initial design evaluations, advocated for the MG-42's high cyclic rate approach to overcome the MG-34's complexity problems. He examines Dietrich's test logs with professional skepticism, reads the zero stoppage notation, studies the barrel condition after sustained fire. His engineering background demands verification. The numbers seem impossible. No automatic weapon achieves zero malfunctions across 1,500 rounds. German testing protocols account for stoppages as inevitable mechanical reality. Acceptance criteria allow up to 50 stoppages per 1,000 rounds, and still classify weapons as combat suitable. Schreiber orders a second sustained fire evaluation, different ammunition lot, different test crew. Eliminate any possibility of measurement error or observer bias. Weber loads a fresh 250-round belt. They fire the complete belt without pause. Reload. Fire again. 600 rounds. 800. 1,000. The M2 continues cycling with mechanical precision that defies Schreiber's experience. At 1,100 rounds, Schreiber himself takes the trigger, feels the weapon's massive recoil driving back into the mount. Each shot sends the entire barrel assembly backward before the spring returns it to battery. The violence of the mechanism should destroy itself. Instead, it operates with reliability that mocks 3 decades of German gas operation advocacy. They cease fire at 1,200 rounds. Ammunition exhaustion again. Schreiber examines the weapon, records 1 stoppage. A failure to feed at round number 973, caused by a damaged cartridge case rather than weapon malfunction. The defective round ejected cleanly. The crew cleared the stoppage in 4 seconds, resumed firing, 1 stoppage in 1,200 rounds. 0.083 stoppages per 1,000 rounds fired. Schreiber's own MG-42, tested 3 months earlier using identical protocols, recorded 21 stoppages across the same round count. The German officer stares at the American machine gun. His career built on the principle that sophistication produces superiority, that precision engineering creates competitive advantage. The M2 proves the opposite. Crude simplicity survives conditions that destroy refined complexity, but Schreiber notices something else, something Dietrich's initial report overlooked. The cyclic rate seems slower than American specifications suggested. Field reports from Tunisia indicated the M2 fired at 800 rounds per minute, comparable to the MG-34, superior to most Allied machine guns. This weapon fires noticeably slower. Weber conducts a precise cyclic rate measurement, 10-second burst with mechanical timing, count the rounds fired, multiply by 6. The M2 heavy barrel records 527 rounds per minute, not 800. The discrepancy demands explanation. Schreiber requests technical documentation captured with the weapon. American field manuals. Maintenance guides. Any documentation that might clarify the rate of fire confusion. The intelligence section provides a water-damaged copy of War Department Technical Manual TM9-225. Browning machine gun, caliber .50, M2. The manual reveals multiple M2 variants. The M2 heavy barrel for ground use fires 450 to 575 rounds per minute. The water-cooled M2 for anti-aircraft applications achieves 450 to 600 rounds per minute, but the AN/M2 aircraft version, with lighter barrel and modified recoil spring, fires 750 to 850 rounds per minute. German intelligence confused aircraft and ground variants, assumed all M2 designations shared identical specifications. The error matters less than the realization it prompts. Americans build different versions of the same weapon for different roles. German industry struggles to maintain production of two general-purpose machine gun types. American industry produces specialized variants of multiple machine gun families simultaneously. The resource implications stagger even Schreiber's trained analytical mind. Each M2 variant requires separate production lines, different tooling, distinct parts inventories. The logistical complexity should create bottlenecks and shortages. Instead, American forces deploy all variants in abundance that suggests unlimited industrial capacity. Field reports from every combat theater confirm this abundance. Oberst Gunther Rahl commanded a Panzergrenadier regiment in Tunisia during February's fighting. His after-action report described American armored formations that mounted M2 heavy barrels on every Sherman tank, half-track, and truck. Weapons used not for defensive necessity but for casual fire superiority. American vehicle columns conducted reconnaissance by fire, spraying .50 caliber rounds at suspected enemy positions while advancing, expending hundreds of rounds to suppress threats that might not exist. German doctrine forbade such ammunition waste. Each machine gun round represented industrial capacity, transportation resources, and ammunition production that German logistics could barely sustain. Rahl's report documented American crews firing 200 to 300 rounds per vehicle during routine movement, tactical abundance that German forces could not comprehend. Hauptmann Ernst Bauer, commanding a panzer company near Sbeitla, filed a report that Schreiber reviews at Kummersdorf. Bauer's Tigers engaged American Sherman formations on February 22nd. His Tigers possessed superior armor and firepower, should have dominated the engagement, but American Shermans mounted M2 Brownings that subjected his tanks to sustained .50 caliber fire from ranges exceeding 800 meters. The rounds failed to penetrate Tiger armor, but they struck vision ports, damaged periscopes, forced commanders to close hatches and fight buttoned up, reduced visibility and situational awareness. Meanwhile, the American tanks maneuvered using their superior mobility while maintaining continuous suppressive fire that pinned German infantry support. Bauer lost 2 Tigers not to Sherman main guns but to mechanical breakdowns while withdrawing under constant M2 fire. His report noted that American crews fired the heavy machine guns continuously for 10 to 15 minutes without pausing for barrel changes. Expended ammunition quantities his own troops could not match in 3 days of combat operations. The psychological dimension emerges in reports from the Eastern Front. Lieutenant Otto Schneider commanded an MG-42 section in the 1st Panzer Division near Kharkov in March 1943. His unit captured an M2 heavy barrel from a destroyed American-supplied Lend-Lease Sherman in Soviet hands. Schneider test-fired the weapon using captured ammunition. His report to division headquarters captures the cognitive dissonance German crews experienced when confronting American firepower. The enemy weapon weighs 3 times our MG-42, fires half as fast, uses obsolete design principles our engineers rejected in 1920, yet it operates with reliability we cannot match. The weapon's mass allows sustained fire, our doctrine prohibits because our barrels would fail. American crews apparently receive so much ammunition they need never conserve fire. We fight with superior training, superior tactics, and superior weapons technology. The enemy fights with unlimited industrial production. We win battles through skill and determination. They win through weight of materiel that our forces cannot match even in victory. Schneider's analysis reveals the fundamental shift in warfare that the M2 represents. German military tradition emphasized the primacy of human factors: leadership, training, morale, the fighting spirit that German doctrine called Kampfgeist. These intangible qualities supposedly overcame material disadvantages. German forces proved this principle in Poland, France, and the early Eastern Front campaigns, but the M2 demonstrates warfare transformed by industrial capacity to a degree that training and spirit cannot overcome. The weapon itself represents modest technological advancement. American engineers made no breakthrough in metallurgy or mechanical design. They simply built a heavy, simple machine gun and provided unlimited ammunition to feed it. The combination proves devastating, not because of innovation, but because of abundance. Schreiber's final evaluation report reaches Wehrmacht High Command on March 9, 1943. His conclusions challenge fundamental assumptions about German military superiority. The report documents the M2's technical specifications without embellishment. Notes its excessive weight, its obsolete operating system, its slower cyclic rate compared to German weapons. Then Schreiber adds the assessment that will haunt German strategic planning for the remainder of the war. The Browning M2 represents American industrial philosophy applied to automatic weapons development, where German engineering emphasizes sophistication, efficiency, and technological advancement. American engineering emphasizes simplicity, robustness, and mass production. The M2 weighs 84 pounds because American industrial capacity treats steel as an abundant commodity rather than a strategic resource requiring conservation. The weapon fires 500 rounds per minute because American ammunition production supports sustained fire that German logistics cannot match. The M2 uses recoil operation because the system requires fewer precision parts and tolerates manufacturing variances that would cause gas-operated weapons to malfunction. German weapons represent superior engineering. American weapons represent superior resources. In extended warfare, resources defeat engineering. The enemy possesses industrial capacity that allows them to build adequate weapons in quantities we cannot match regardless of our technological superiority. They compensate for engineering limitations through supply abundance that renders our advantages irrelevant. The report circulates among Wehrmacht technical commands throughout spring 1943, generates intense discussion. Some officers dismiss Schreiber's conclusions as defeatism, argue that German engineering superiority will ultimately prevail. Others recognize the implications with growing concern. General Major Hermann Hoth, commanding 4th Panzer Army on the Eastern Front, reads the report in late March, requests additional analysis. His forces face increasing numbers of American-supplied weapons in Soviet hands. M2 Brownings mounted on Sherman, tanks, M1919 machine guns equipping rifle units. The abundance of American automatic weapons transforms Soviet defensive positions into fortresses of overlapping machine gun fire. Hoth's intelligence staff compiles production statistics that confirm Schreiber's assessment. German factories produced 12,500 machine guns in February 1943, all types combined: MG-34S, MG-42S, aircraft weapons, anti-aircraft guns. American factories produced 53,000 machine guns in the same month, more than 4 times German output. And American production increased monthly, while German production struggled to maintain even current levels. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The ammunition disparity proves even more dramatic. German ammunition production in early 1943 averaged 700 million rounds monthly across all calibers. American production exceeded 2 billion rounds monthly, nearly 3 times German output, and American forces consumed ammunition at rates German logistics could never sustain. Field reports document American squad-level automatic weapon employment that consumes more ammunition than entire German companies received in a week. Bar gunners in American infantry squads fired 300 to 500 rounds daily during active operations. German MG-34 and MG-42 gunners received 150 to 250 rounds daily, half the ammunition supporting weapons that fired twice as fast. The mathematical progression favored American victory through attrition, regardless of tactical skill or technological superiority. German forces won individual engagements through better training and leadership, but they consumed irreplaceable resources, while American forces operated with supply margins that treated ammunition as nearly infinite. Hauptmann Dietrich understands these implications as he completes his testing at Kummersdorf in mid-March. The M2 sitting on his Proving Ground test mount represents more than an automatic weapon. It embodies American industrial might converted to battlefield effect. Every component in the weapon connects to vast production networks: steel mills processing ore from Minnesota's Mesabi Range, factories in Massachusetts and Connecticut forming receivers and barrels, chemical plants in Delaware producing powder and primers, transportation networks moving raw materials and finished weapons across a continent immune to enemy bombing. The German machine gun industry operates under constant Allied air attack. Factories damaged or destroyed require months to rebuild. Worker casualties reduce production capacity. Raw material shortages force compromises in metallurgy and manufacturing processes. Yet German weapons like the MG-42 still demonstrate remarkable sophistication and performance. American weapons need not achieve German sophistication. They need only achieve adequate performance in overwhelming quantities. The M2 weighs 84 pounds because American factories treat 75 pounds of excess steel as acceptable if it ensures reliability. German engineers optimize every gram because steel allocation limits force weight reductions. American ammunition expenditure rates seem wasteful because American production treats 1,000 rounds as replaceable. German ammunition conservation seems wise because German production struggles to manufacture replacement rounds at any price. Dietrich writes a personal postscript to his official testing report, an observation that will never appear in Wehrmacht records, but which captures the psychological dimension of Germany's confrontation with American industrial warfare. We test captured weapons to identify technological advantages or vulnerabilities our forces can exploit. The M2 Browning possesses no technological advantages. Its design is crude, its weight excessive, its operating system obsolete. Yet it operates with reliability our sophisticated weapons cannot match and represents production capacity our industry cannot approach. The enemy wins not through innovation but through abundance. They build adequate weapons in overwhelming quantities. They supply these weapons with ammunition our forces would consider wasteful. They replace losses faster than combat can inflict them. Against such industrial capacity, our technological superiority proves insufficient. We possess better weapons, they possess more weapons. In extended warfare, more defeats, better. The testing continues through March and April 1943 as more captured M2s reach Kummersdorf from Tunisia, Italy, and the Eastern Front. Each weapon confirms the initial assessment, 0 to 3 stoppages per 1,000 rounds across all test samples. Barrel life exceeding 95,000 rounds before replacement. Reliability under mud, dust, and thermal stress that destroyed comparable German weapons. Oberst Schreiber requests permission to reverse engineer the M2 for German production. His proposal suggests simplifying German machine gun design, accepting greater weight in exchange for improved reliability, adopting recoil operation to reduce precision parts requirements and improve manufacturing efficiency. The Heereswaffenamt rejects the proposal in May 1943. Germany lacks the steel allocation to build 84-pound machine guns in tactically useful quantities, cannot retool factories already strained to produce existing weapon types, most critically, possesses no ammunition production capacity to support American-style sustained fire doctrine, even if weapons could be manufactured. Germany must continue with its existing machine gun families, hope that tactical skill and defensive advantages offset growing Allied material superiority. Accept that German weapons represent superior engineering applied with the resource constraints that make American-style industrial warfare impossible. The M2S captured at Kummersdorf remain in German hands through 1944, used for training, helping German troops identify American weapons and understand their capabilities. Some captured examples see field use by German units desperate for any functional automatic weapons after Allied bombing destroys machine gun production facilities. German troops who operate captured M2S invariably report the same observations. The weapon weighs too much for infantry carry, fires too slowly compared to the MG42's impressive cyclic rate, but it functions continuously under conditions that silence German weapons. Never requires the careful maintenance that keeps MG34S and MG42S operational. Never suffers the feed problems and stoppages that plague German guns during sustained combat. Most significantly, captured M2S arrive with ammunition supplies that German crews consider excessive. American weapons captured in Tunisia carry 500 to 1,000 rounds per gun, more ammunition than German machine gun sections receive for entire operations. American crews treat 100-round belts as minimal basic load, fire full belts during brief engagements, reload with fresh belts while German gunners carefully measure 5-round bursts to conserve scarce ammunition. Lieutenant Franz Müller commanded a Fallschirmjäger unit near Cassino in Italy in early 1944. His section captured an M2 from a destroyed American vehicle in February. Müller used the weapon for 3 weeks before ammunition exhaustion forced its abandonment. His diary entries capture German soldiers' evolving understanding of American firepower. February 12th. The American machine gun fires continuously. We expend more ammunition in 20 minutes than our own weapons receive in 3 days. The psychological effect on enemy forces is profound. They cannot advance under such fire, even though we lack the infantry strength to defend our position otherwise. February 18th. Ammunition expenditure concerns me. We have 900 rounds remaining for the captured weapon. At current rates, this represents perhaps 3 hours of combat operations. Our own MG42S would last a week on such allocation. Yet the American weapon's sustained fire achieves suppressive effect. Our more sophisticated guns cannot match despite their superior cyclic rate. February 27th. Ammunition exhausted. We abandoned the American weapon when withdrawing from advanced positions. The gun functioned perfectly throughout 3 weeks of combat, in mud, rain, and continuous firing. Never required maintenance beyond basic cleaning. Never malfunctioned despite conditions that caused our MG42 to jam repeatedly. The weapon's reliability is extraordinary, but without American supply abundance to feed it, the M2 becomes useless steel. Müller's observations reveal the central irony of German encounters with captured M2 Brownings. German troops recognized the weapon's reliability and appreciated its sustained fire capability, but they could not replicate American employment doctrine because German logistics could not support American ammunition consumption rates. The captured weapons worked perfectly. German supply systems could not feed them adequately. American industrial capacity created weapons designed for abundance. German resource scarcity demanded weapons designed for conservation. The fundamental mismatch extended beyond mechanical engineering to industrial philosophy and national resources. By autumn 1944, German testing of captured M2S becomes irrelevant. Allied material superiority overwhelms any tactical advantages German forces achieve through training or technology. American production exceeds 100,000 machine guns monthly. Ammunition output approaches 3 billion rounds monthly, numbers that render German countermeasures meaningless. German soldiers facing American forces in France, Italy, and eventually Germany itself report the characteristic sound of M2 fire with fatalistic acceptance. The deep hammering reports signal American presence, guaranteed fire superiority, unlimited ammunition supporting offensives that German forces cannot match regardless of fighting skill or defensive preparation. Feldwebel Heinrich Braun, MG42 gunner with the 352nd Infantry Division in Normandy, survived the June 1944 Allied invasion. His account describes American firepower from the German defensive perspective. They advanced behind a wall of machine gun fire. Every vehicle mounted at least one heavy machine gun. Every position supported by multiple weapons firing continuously. We responded with careful aimed bursts. Conservation, our doctrine demanded. They fired without pause, without concern for ammunition expenditure, without apparent awareness that machine gun doctrine required fire discipline. Their profligacy proved more effective than our precision. We achieved better hit ratios per round fired. They achieved better suppressive effect through volume. We conserved ammunition as training demanded. They expended ammunition as if supply were infinite. For them, it was. Our positions held until ammunition exhaustion forced withdrawal. Their positions held indefinitely because exhaustion seemed impossible. Braun's experience repeated across every front where German and American forces engaged. German tactical superiority proved insufficient against material abundance. German weapons technology could not compensate for supply scarcity. German soldiers fought with courage and skill that won tactical engagements. American soldiers fought with material support that won strategic campaigns. The captured M2 Brownings tested at Kummersdorf remained in German hands until Soviet forces overran the proving ground in April 1945. The weapons survived testing, field evaluation, and 5 years of war in better condition than German machine guns manufactured months earlier. Simple mechanisms tolerated use that destroyed sophisticated designs. Heavy construction absorbed stress that fractured lighter components. Recoil operation continued functioning after gas systems failed from fouling and maintenance neglect. The final German evaluation of the Browning M2 appears in a classified Heereswaffenamt technical summary, dated April 7, 1945, written as Soviet artillery bombards Berlin, compiled by officers who understand that German defeat is imminent. The document represents not weapons assessment but historical epitaph, an acknowledgement of how industrial warfare transformed military competition in ways German strategic planning never anticipated. American automatic weapons demonstrate adequate technical performance, supported by unlimited industrial production. German automatic weapons demonstrate superior technical performance constrained by insufficient industrial capacity. In modern warfare, adequate weapons in overwhelming quantity defeat superior weapons in limited supply. The enemy understood this principle. We did not. Hauptmann Klaus Dietrich survives the war, returns to civilian life in a Germany divided and occupied. His expertise in weapons engineering finds employment with British occupation authorities documenting captured German technology. In 1947, he writes a memoir never published, Personal Reflections on 5 Years Evaluating Enemy Weapons at Kummersdorf. One chapter focuses entirely on the M2 Browning. Dietrich describes his initial dismissal of the weapon's crude design, his growing respect for its mechanical simplicity, his eventual understanding that American engineers solved different problems than German designers addressed. Germans optimized for technological sophistication within resource constraints. Americans optimized for reliability within resource abundance. Different starting assumptions produced different solutions. In extended warfare against an industrial power, American assumptions proved correct. Dietrich writes one passage that captures the psychological impact of confronting American industrial warfare through the lens of a single weapon. We believed engineering excellence would compensate for material limitations. We convinced ourselves that our sophisticated weapons, our superior training, our tactical innovation would overcome the enemy's crude abundance. The M2 Browning taught us otherwise, not because it was a better weapon in any technical sense, but because it was an adequate weapon produced in quantities and supplied with ammunition in volumes that rendered our sophistication irrelevant. They won not by building better machine guns. They won by building enough machine guns that technical superiority ceased to matter. They fired 1,000 rounds where we fired 100, replaced losses faster than combat could inflict them, supplied their forces with material abundance that transformed warfare from a test of skill to a contest of resources. Against such industrial capacity, our technical advantages proved meaningless. We possessed superior weapons, They possessed sufficient weapons in overwhelming quantity, sufficient defeated superior. Lieutenant Friedrich Weber, Dietrich's assistant during the Kummersdorf testing, emigrates to the United States in 1949, finds work as a mechanical engineer in Detroit's automobile industry. In 1953, he tours the Saginaw steering gear division of General Motors, the same facility that produced 393,000 M1919 Browning machine guns during the war, now converted back to automotive component production. Weber examines the production lines with professional fascination. The equipment that formed machine gun receivers now stamps automotive parts. The assembly stations that built weapons now assemble steering columns. The same manufacturing philosophy that produced adequate weapons in overwhelming quantity now produces adequate automobiles in mass market volumes. American industrial culture treats volume production as more valuable than artisanal quality, accepts standardization over customization, prioritizes availability over excellence. Weber writes to his former commander describing the experience. His letter captures how German technical professionals struggled to reconcile their engineering education with American industrial reality. They treat manufacturing as Americans treat warfare, overwhelming problems through volume rather than solving problems through elegance. Their production lines value efficiency over sophistication. Their designs prioritize simplicity over technological advancement. They build adequate products in quantities that dominate markets through availability rather than superiority. This philosophy produced the M2 Browning, not an excellent weapon by German engineering standards, but an adequate weapon manufactured in quantities that made excellence irrelevant. The same philosophy now produces automobiles, appliances, and consumer goods that flood global markets not through superiority, but through availability. Americans won the war using industrial principles we dismissed as crude. They dominate the peace using the same principles we still fail to understand. The M2 Browning continues in American military service long after the war ends. Korea, Vietnam, Persian Gulf, Afghanistan, Iraq. The weapon John Browning designed in 1921 remains operational a century later, not because of technological superiority, but because simple mechanisms require less maintenance, tolerate greater abuse, and survive longer than sophisticated alternatives. Modern American forces still mount M2s on vehicles, aircraft, and defensive positions. The basic design remains unchanged: 84 pounds, recoil-operated, 450 to 575 rounds per minute, cyclic rate. The same specifications that German engineers at Kummersdorf evaluated in 1943. Meanwhile, the MG-34 and MG-42 that German designers celebrated as technically superior evolved into new weapons systems. The MG-3, modified and updated, chambered for NATO standard ammunition, served successfully for decades, but the original wartime weapons required replacement. Precision components wore out. Maintenance demands exceeded post-war logistics capabilities. Technical sophistication became liability when abundance shifted to scarcity after German defeat. General Major Hermann Hoth, who read Oberstschreiber's evaluation in spring 1943, survived the war in Soviet captivity. Released in 1955, he spends his retirement years writing military history. His analysis of the Eastern Front includes extended discussion of German tactical excellence defeated by Soviet material superiority. American Lend-Lease equipment features prominently: Shermans, trucks, aircraft, and machine guns. Hoth writes one passage about encountering M2-equipped Soviet forces near Kursk in July 1943. His account describes German tactical superiority rendered meaningless by material abundance. Soviet defensive positions bristled with American weapons: Shermans mounting M2 Brownings, infantry positions equipped with M1919 machine guns. The abundance transformed Soviet defensive capability. Where previously we achieved tactical victory through superior training and weapons, we now faced defensive fire volumes our own weapons could not match despite technical superiority. The psychological impact exceeded the tactical effect. German soldiers understood that enemy fire represented unlimited industrial production. Each engagement consumed their limited ammunition, while the enemy fired as if supply were infinite. The mathematical progression favored Soviet victory through attrition. Our tactical excellence could not overcome their material abundance. We fought better. They fought longer. In extended warfare, longer defeated better. Hoth's analysis captures how individual weapons like the M2 Browning represented broader strategic realities. German forces possessed technological sophistication, tactical excellence, and operational skill that won countless battles, but they faced enemies whose industrial capacity sustained material abundance that rendered German advantages insufficient. Soviet manpower, American production, British resilience, the combination proved overwhelming regardless of German military competence. The M2 embodied this dynamic in steel and mechanics, not an excellent weapon by German engineering standards, but an adequate weapon produced in overwhelming quantity, supplied with unlimited ammunition, employed with casual abundance that German logistics could never match. The sum of adequate performance and industrial abundance defeated sophisticated technology, constrained by resource scarcity. Oberst Heinrich Schreiber, whose evaluation warned Wehrmacht command about American industrial capacity, spent the final war years attempting to rationalize German production. Simplify designs, reduce precision parts requirements, increase output through manufacturing efficiency rather than technological sophistication. His proposals mostly failed. German industry lacked time, resources, and cultural willingness to abandon engineering excellence for production volume. Schreiber wrote in his post-war memoir about this cultural barrier. German engineering tradition valued elegance, sophistication, technical advancement. These values produced superior weapons within peacetime constraints, but warfare revealed that adequacy in abundance defeated excellence in scarcity. German culture could not adapt quickly enough to this realization, could not abandon deeply held beliefs about engineering excellence, even when survival demanded it. We understood intellectually that American industrial capacity would defeat us. We could not accept emotionally that our superior weapons and superior training proved insufficient against their adequate weapons in unlimited supply. The M2 Browning demonstrated this truth in early 1943. We continued fighting as if superior quality would eventually overcome abundant quantity. It never did. Could never do so against an enemy whose factories outproduced our entire industrial base while remaining immune to our counterattack. The post-war period brought additional revelations about American production capacity. Statistics declassified in the 1950s revealed the true scale of American machine gun manufacturing. Over 2 million M2 Brownings produced between 1941 and 1945. More machine guns than Germany manufactured across all types during the entire war. American factories built these weapons while simultaneously producing tanks, aircraft, ships, trucks, and ammunition in quantities that supplied not only American forces but Allied militaries worldwide. The ammunition production figures proved even more staggering. American factories manufactured 47 billion rounds of small arms ammunition during the war. 47 billion rounds supporting forces that consumed ammunition at rates German logistics considered impossible. American infantry companies fired more ammunition daily than German divisions received weekly. The disparity exceeded every wartime German intelligence estimate. Hauptmann Ernst Bauer, whose Panzer Company faced M2-equipped Shermans in Tunisia, survives the war in American captivity. After release in 1946, he corresponds with American tank crews he fought against. One exchange particularly strikes him. An American Sherman commander describes ammunition allocation for his platoon's M2 Brownings. 5,000 rounds per weapon, per engagement. 15,000 rounds total for 3 tanks. More ammunition than Bauer's entire Panzer Company, received in a month of continuous operations. The American crew expended their entire allocation during a 6-hour engagement, received full replacement ammunition the following day. Bauer's company rationed ammunition for 3 months after Tunisia, never received full replacement, eventually withdrew from combat due to ammunition exhaustion rather than tactical defeat. The comparison crystallized post-war German understanding of why tactical excellence proved insufficient. Bauer writes one observation that other German veterans repeatedly echo in memoirs and histories. We fought a 20th century war with 19th century logistics. They fought a 20th century war with 20th century industrial capacity. Our weapons matched or exceeded theirs technically. Our tactics proved superior repeatedly. Our training and leadership surpassed theirs in most engagements, but they possessed industrial capacity that rendered these advantages meaningless. They replaced losses faster than we inflicted them. They supplied their forces with abundance we could never match. They won through resources applied relentlessly rather than through tactical brilliance deployed sparingly. The M2 Browning represents this dynamic in miniature, a single weapon embodying industrial warfare's transformation of military competition. German engineers examined the weapon seeking technological secrets to exploit, found instead a philosophy they could not replicate. American designers accepted greater weight because steel was abundant, embraced mechanical simplicity because sophistication created failure points, prioritized reliability because replacement weapons were readily available, but weapon failures in combat were unacceptable. German designers optimized differently, reduced weight because steel was scarce, embraced mechanical sophistication because they believed technical excellence compensated for material limitations, prioritized performance because they assumed superior weapons, offset numerical inferiority. The different optimization produced different weapons, reflecting different industrial realities. In extended warfare against opponents with superior industrial capacity, American optimization proved correct. Adequate weapons in abundance defeated superior weapons in scarcity. Reliability under stress surpassed sophistication under ideal conditions. Simple mechanisms outlasted complex designs. The mathematics favored industrial capacity over engineering excellence. Feldwebel Heinrich Braun, who described American firepower in Normandy, emigrated to Canada in 1951, worked in manufacturing, eventually managed a machine shop producing automotive components. His experience with both German precision engineering and American mass production methods informed his management philosophy. He wrote an essay for a trade publication in 1968 discussing manufacturing approaches. German engineering seeks perfection. American manufacturing seeks adequacy at scale. Both approaches produce functional products. German products demonstrate superior quality in individual comparison. American products dominate through market availability. In peacetime commerce, both approaches succeed. In wartime production, only abundance matters. The enemy who produces adequate weapons faster defeats the enemy who produces superior weapons slower. Markets reward quality. Warfare rewards quantity. Braun's observation extends beyond machine guns to broader questions about industrial competition and national strategy. German forces entered World War II with superior weapons, superior training, and superior tactical doctrine. They achieved extraordinary victories against opponents possessing greater resources, but extended warfare against enemies who could sustain material losses indefinitely eventually overwhelmed German advantages. Superior quality could not compensate for insufficient quantity once warfare became a contest of industrial attrition. The M2 Browning tested at Kummersdorf in 1943 revealed this truth to German technical intelligence. Their evaluation documented the weapon's mechanical crudeness, its excessive weight, its obsolete operating system, then acknowledged its unprecedented reliability and the industrial capacity it represented. German engineers understood intellectually what their findings meant. German strategic planning could not adapt quickly enough to the implications. By 1945, the outcome was inevitable. American industrial capacity combined with Soviet manpower and British resilience overwhelmed German tactical excellence. The Allies possessed adequate weapons in quantities that rendered German sophistication irrelevant. They sustained losses that would cripple German forces. They replaced equipment faster than combat destroyed it. They supplied their armies with abundance that transformed warfare from careful resource management to overwhelming application of material superiority. The sound of American M2 Brownings firing across European battlefields announced this transformation. Deep hammering reports signaled not just weapon discharge, but industrial capacity converted to battlefield effect. Each burst represented steel from American mines, powder from American chemical plants, and transportation networks spanning a continent immune to enemy attack. Each weapon embodied manufacturing capacity that produced adequate solutions in overwhelming quantity, rather than excellent solutions in limited supply. German soldiers learned to recognize the M2's distinctive sound, deeper than the MG-42's buzzsaw snarl, slower than the MG-34's rapid crack, but continuous in ways German weapons could never sustain. The sound meant American presence, guaranteed fire superiority, unlimited ammunition supporting operations German logistics could not match. The psychological impact exceeded the tactical effect. German troops understood they faced not individual opponents but industrial capacity they could never overcome. When Soviet forces captured the Kummersdorf Proving Ground in April 1945, they found the M2 Brownings still functional, still maintaining the zero-stoppage reliability that astonished German testers in 1943. The weapons survived 5 years of war, testing and use in better condition than German machine guns manufactured months earlier. Simple mechanisms tolerated abuse that destroyed sophisticated designs. Heavy construction absorbed stress that fractured lighter components. American industrial philosophy proved correct, not through innovation, but through understanding that adequacy in abundance defeats excellence in scarcity. The broader lesson extends beyond automatic weapons to industrial warfare itself. Nations entering modern conflicts must understand that sustained operations demand industrial capacity, exceeding tactical requirements. Superior weapons provide advantages in individual engagements. Adequate weapons in overwhelming quantity provide advantages in strategic campaigns. Technology alone cannot compensate for insufficient production. Training alone cannot overcome material inferiority. Tactical excellence cannot substitute for industrial capacity in extended warfare against opponents who can sustain losses indefinitely. Germany learned this lesson through defeat. The M2 Browning represented the principle in tangible form. American engineers built not the best possible machine gun, but an adequate machine gun that American industry could produce in overwhelming quantity. They supplied these weapons with ammunition in volumes German logistics considered wasteful. They employed these weapons with casual abundance that German tactical doctrine considered irresponsible. The approach succeeded not through sophistication but through resources. American forces won not by fighting better, but by fighting longer with material support that sustained operations. German forces could not match. The M2 embodied this strategy. Heavy, simple, reliable, available in quantities that transformed automatic weapons employment from defensive necessity to offensive abundance. Hauptmann Klaus Dietrich understood this truth when he completed his evaluation in March 1943, wrote his conclusion, knowing it challenged everything his engineering education taught him. Superior design did not guarantee superiority. Technological advancement did not ensure victory. In warfare between industrial powers, production capacity mattered more than engineering excellence. Adequate weapons in abundance defeated superior weapons in scarcity. Americans understood this principle. Germans did not until too late. The M2 Browning fires today on ranges and battlefields worldwide. Still heavy, still recoil-operated, still firing 500 rounds per minute from mechanisms John Browning designed in 1921. Still demonstrating that simple solutions produced in abundance defeat sophisticated solutions constrained by scarcity. The weapon's century of service proves American industrial philosophy correct, not because the M2 represents superior engineering, but because it represents adequate engineering produced in overwhelming quantity and supported by industrial capacity that treats machine guns as replaceable commodities rather than precision instruments. German gunners at Kummersdorf in 1943 refused to believe the M2's 800 round per minute fire rate because the weapon they tested fired 527 rounds per minute. The confusion revealed deeper misunderstanding. They sought technological advantage to exploit, found instead industrial philosophy they could not match, discovered that warfare had transformed into a contest they could not win, regardless of technical superiority or tactical excellence. The M2 spoke with the voice of American factories, continuous, reliable, adequately effective, and overwhelmingly abundant. That voice echoed across every battlefield where American and German forces engaged, announced not just automatic weapons fire but industrial supremacy that rendered German sophistication insufficient. The sound meant American presence, unlimited ammunition, fire superiority sustained by production capacity Germany could never approach. When the last shots fired across Europe in May 1945, they included M2 Brownings still functioning flawlessly, still demonstrating reliability that German weapons could not match, still embodying the principle that adequacy in abundance defeats excellence in scarcity. The weapons outlasted the war, outlasted German resistance, outlasted the belief that engineering sophistication compensates for industrial insufficiency. The lesson remains relevant. Modern warfare still rewards industrial capacity over individual weapon superiority, still favors adequate solutions produced abundantly over excellent solutions produced sparingly, still demonstrates that sustained operations demand resources exceeding tactical requirements. The M2 Browning taught this lesson in 1943. The weapon's continued service proves the lesson's enduring validity. German engineers who evaluated captured M2s learned too late that they fought the wrong war, optimized for quality when warfare demanded quantity, pursued technological excellence when industrial capacity mattered more, built superior weapons their nation lacked resources to produce in decisive quantity. The M2 represented different choices, adequate rather than excellent, heavy rather than light, simple rather than sophisticated, available in quantities that rendered German advantages meaningless. In the end, adequacy overwhelmed excellence, abundance defeated scarcity, industrial capacity overcame technological sophistication. Americans won not by building better weapons, but by building enough weapons that better ceased to matter. The M2 Browning embodied this victory, not through innovation, but through understanding that modern warfare rewards production capacity more than engineering genius. Simple solutions produced abundantly outlast sophisticated solutions produced sparingly. In warfare between industrial powers, quantity possesses a quality all its own. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out. And don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.